All right, we'll get started now, and hopefully we'll have more join. Welcome, everyone, to the second of our Bioconductor Developer Series. It's a real pleasure to introduce Naris Balasubramanian from Stanford University, who's going to talk to us about CVXR. Just before we go into that, I'll just do two quick shout outs. So one on Thursday, I think a little bit earlier in the day at Developers Forum, Anthony Christidis from Harvard Medical School and Ludwig Geistlinger will be talking about, I think, vibe coding on a bioconductor seminar. And those of you that are paying attention to the mailing list, Sean Davis just posted some notes that he'd put together for the hackathon in Venice. We're really looking for new ideas. So anybody who is aware of some tools or people that are working in this space that have interesting things to say, please do let Erica or myself know, and we'll try to schedule more folks. I think it's a really exciting time for us to start seeing, what kinds of things can we use large language models and especially the sort of coding agents for. Bioconductor has some special requirements, I think, at times where we tend to be a very collaborative organization, and I haven't seen very much good guidance on how to sort of have 3 or 4 people with their different coding agents working on the same project. But I'm sure we'll end up having to be able to do those kinds of things at some point. Anyways, without taking up more time, Naris, let me turn it over to you. It's a real pleasure. Thank you very much for coming.
All right. Thank you very much, Robert. So I just want to sort of preface this by saying that although this talk is titled Development for Plans for CVXR, I hope to give you at the end at least something that's a more bioconductor specific. I just managed to put that together this morning. But I think I'm going to quickly go through this part because this, I think, is a little bit of I call almost ancient history a little bit at this point. So I just wanted to say that around December of last year, I started seriously looking into, this LLM for help agents for coding and so on. And so I made a dedicated study. And those of you who know me, I know that I hike a lot. And throughout I had a long-standing project that was to say that I needed CVXR, which is an optimization, convex optimization infrastructure, DSL actually in R. I wanted to sort of keep it, up to date with CVXPy, its sister project, and we had gotten far behind. The reason was that the only 2 developers were myself and Angie had already graduated. She is a Stephen Boyd student, and so essentially it ended up being just me. And so the problem was that, this is not code that you could sort of just have people who are, who know, even those of you who know, those people who are very good at R, it's not enough to know that. You also need to know some, real convex optimization to be able to do that. So it became really increasingly hard to sort of keep up, and we have gotten very far behind. So that was the reason that I actually sort of started on this project. And luckily enough, on my hikes, every time I went, I would actually make notes about this. So 2 years of notes were on my phone that I could look back upon what I wanted to do and what my ideas were. And so long ago, the first CVXR release, by the way, was using S4. And so I had sort of thought about how do I even manage to keep up with CVXPy? And I thought about this, idea of somehow mirroring the parts of CVXPy so that I could keep up, not just catch up, but also keep up. And today I'm going to tell you a little bit about how LLMs helped me do that. So, okay, without further ado, let me start. So this part, which I'll go through quickly, is, a talk I gave at the CVXPy workshop. This was meant to be a joke. I said, okay, this is what I did. And in the end, I had a working CVXR, but that was just a joke. But I think what actually happened was the fact that I had to sort of, work a little bit to make the R port of CVXPy work. So again, I already told you that I had fallen behind in CVX in features compared to CVXPy. We were at version 1.0.15, which is, with S4 classes, and CVXPy had marched on to 1.8.1 at that time. So how do we catch up? And so there are two major developments that actually made me, think positively about this. One is these AI development tools that could write out code pretty fast and good code. And then second, the new facilities in R, which especially these S7 classes, which I'd been watching for a while. I know Michael, I don't know whether he's on or not, but he'd been involved with that as well. So I think this part I'm going to skip through and so on, just because we all are experts here. So I just wanted to sort of remind us that, there are several object systems in R. I was talking to a Python community here, so I had to sort of give them an idea of what these things were. And I think the main thing I was trying to say is, okay, this new thing that came along in 2024 was this S7 classes. And just to give orient you as to the code in old CVXR, this was as an actual implementation of the absolute atom in CVXR. And of course, there's a lot of, set methods and generics that you have to define and so on and so forth. But we had to do this for hundreds of atoms like this. And then, so it actually was quite a bit of typing too, not just keeping up with the CVXPy. Also in CVXPy, we have a very nested structure tree. It has a sort of there could be name clashes, for example. We have, sum.py under affine. You also have an axis atom sum.py. So the first question I had to think about was, okay, how do you manage to do this in R? So this was an easy problem to solve, because what you could do is basically somehow have a script that puts things in the right collate order under the R tree. So I had actually already started doing this, and I actually implemented this for the S4 classes. And I actually, if you look in my tree, you'll see somewhere there's a branch that is orphaned at this point that actually had all these things already there. But even then, despite that, the progress was very, very hard because of the fact that it was just one person. So what we ended up doing, incidentally, is to not just think about catching up to CVXPy, but also making sure that we could actually, keep going, matching the versions one by one. So we developed in an isomorphic tree. So for example, here, there's actually a development repo for CVXR, which actually has this structure. So the R source tree basically matches exactly what the CVXPy tree looks like. And every file has this annotation on top. This is the kind of bookkeeping that, really these tools are very good at. So no problem getting there. So I had one script, automatic, reversible, that could always sort of put things in the right place under the /r in my package. Next, the absolute class, for example, if you take the same thing if you compare this with the S4 system, it's a lot cleaner. It also looks like it almost mirrors Python a little bit. So I think that this was clean, compact, and we had one file for atom like this. So we could put it all together. And so it was already kind of beginning to match the Python structure pretty well. So here's a side-by-side comparison, for example, of the Python class and the S7 class. And you can see there's almost one-to-one correspondence. Okay, so this is where we thought, okay, an AI can help us do this. So, we tried this, and I really thought it was an experiment, by the way. I just thought, one day, just 10 days before the CVXPy workshop, I said, oh my God, I'm supposed to give a talk on CVXR. Had not done anything. So I'd at least sort of do some experiment and report on the experiment. So I started it really as an experiment. And what I did was I first, talked about the fact that, I already had the this isomorphic file structure. I pointed the Claude at that structure and said, I want to follow this discipline all the time. And then I came up with a few architectural constraints, especially involving, for example, I was really concerned about the operator dispatch on S7 because this is a DSL. So you need to be able to add expressions, multiply expressions, and so on in the CVXR realm. And everything has to be, yield the right result. So I sort of put down a few architectural constraints. And as I went through, first thing I do, by the way, again, Robert also told me that it would be nice to sort of say a few words about what made things successful. So in the middle of these kinds of explorations, I'll also throw out a few things that worked for me. What I always do is when I have a problem like this, I first ask it to come up with a plan. So I always say, think of yourself as both an R and I send a prompt to an agent saying, you're an R and Python data science expert. I want you to study my documents thoroughly, deeply, no skimming, almost like a child. I try to be as pedantic as possible, no skimming. And I want you to come back and present to me a plan how you would do this. And so we've iterated a few times and so on. And so I came up with this idea that also I needed to have all the tests also mapping to CVXPy. And so with those kinds of, guardrails and so on, I was able to proceed pretty fast. And so, there were the foundation, I just got 95 files defining the foundation. Then I went up to expressions, atoms, and I decided to focus on 2 solvers initially so that I can get the things working. And then I worked on to, sparse matrices. And I got pretty quickly to, release 1.8.1, I'd say in a matter of, you'll see it in the end, in a matter of days. And that's what I presented. And the rest that follows release 1.8.1 is what the current version is. So the design choices that mattered here was simple things like isomorphic file tree, S3 ops handler, and I'll discuss this in detail. Luckily, I also have this canonicalization code from my old CVXR, which I could just pretty much use unchanged. That was fine. And then I also managed to actually implement caching more carefully so that, those of you who have worked with CVXR will see that, you describe an optimization problem. The optimization problem has to be canonicalized into a sort of a tree. And that canonicalization process takes a long time. So you don't want to do that over and over again if you're solving the same problem with different values of the parameters. So caching is a really important aspect of it. And then I recorded all the decisions and so on. So the testing also kept us honest. So every test in CVXPy, I wanted a mirror in CVXR. And also because for debugging, I made sure that I asked it to annotate every test with where I could find this in CVXPy also. So this way I could quickly go back and forth. In fact, the LLM could do it for me. I don't even have to worry about it. It can find those things for me. If there's a bug, if somebody reported a bug, I could say, okay, this happened, and figure out where this happened, or some test failed, for example. I could always immediately get that, zero in on it. So several of these things, and so we progressed pretty fast. And as we did this, I also managed to sort of implement things that we always wanted in CVXR that was not there, like discipline geometric programming, which is basically optimization in the log space, and then parameterized programming. This is for just changing parameters and doing fast resolves. This is inspired by GlimNet and things like that. And then quasi-convex programming, and soon I'm going to also add nonlinear programming as well. Plus, I managed to add complex numbers, warm starts. So I was able to implement 13 solvers in a matter of days. And so all of those also could actually do warm starts. Not only was I able to implement the solvers, I was able to update the solver packages, which I also maintain, by the way, on CRAN, to make this possible, to actually fix up some of the warm start issues that they had and so on. And then we added logic items and so on. So all of this is documented on the website. If those of you who want to actually look at it, if you go to cvxr.rbind.io, you'll see the entire website also, all the way with all the working examples for you. So that's where we are at the moment. So again, by the numbers, I was able to get to, some huge number of I made sure that every test in CVXPy had an equivalent in CVXR. So this went pretty fast. I also managed to get some speed efficiency and memory efficiency. Now, I should mention that most of this S4 work in the initial version of CVXR was done by Angie Fu. And it's, by the way, she is, she's an expert Python programmer, and she's also an R programmer. But of course, S4 is a little, it's not trivial to learn. And there were a few things where she could have done things more efficiently, but I still think her work is a tour de force. I don't know how she managed to get all those things done. So hats off to her. I mean, I think that just getting CVXR running was, I think, an impressive feat. So I think that enabled us to sort of do the next iteration of it. So I was able to get there and so on. So where are we? So here's where we are. So if I now, so this is the dramatic thing that I did with, sorry, here we go. This is the dramatic thing that I actually showed the CVXY community. So you can see when I did my first commit, for example. So I started, the first commit was on February 9th, and the workshop was on February 19th or something like that. Okay. So this is where we got to. And let's see. So now, I think that it was mind-boggling to me that in a matter of 10 days, I was able to get that far. So I really thought that, wait a minute, I mean, did I make any mistakes? I mean, and I tried to be very careful about checking all these things because if I'm going to release it on CRAN, I don't want a bunch of people coming at me saying, what crap have you posted? And, what is giving me more problems to solve than were there in the original version of CVXR. So I think the key thing is that this isomorphic file structure, while simple, enables me to have a maintenance strategy. So every time CVXPy tracks a new release, I pin the commit to the repo, and then I actually say, okay, go ahead and figure out, make the differences. I can ask an LLM to do this. I can ask Claude to actually tell me what the diffs are, even if there's a bug fix or something like that. And I can do AI-assisted translation of changed files. And I can also add new tests, and I can repeat and rinse. So every test block, because it's annotated and things like that, I mean, I'm able to go through this pretty fast, and I have breadcrumbs leading me straight back to the CVXY ground truth. So this is a principal process that actually helped me build 1.8.1, but it's not just that. It actually enables me to go further. So this was how I ended this talk. Basically, the key things that helped me was the fact that there was a clean architecture to CVXPy. There's 10 years of community effort. Angie Fu's astonishing S4 work doing CVXR from scratch. And her design thinking sort of helped me carrying forward. For example, her solver structure, I pretty much ported directly over that. And then S7 at the right moment, because here's an OOP paradigm that maps pretty close to Python. So I think I was lucky because I chose the project wisely. I chose a translation project. I didn't choose a project from scratch, but I'll tell you later that I've been successful with those as well. Okay, so I have these are various aspects that I think helped me in the process. So I was able to do this in 10 days. And that was February. People were impressed when I gave this talk. Now, the next question is the proof of the pudding is, are you able to keep up with CVXPy? Because CVXPy is now at version 1.8.2. And if you look at CRAN, we are at version 1.8.2. So actually that vindicates my approach. But there were problems on the horizon. After I released 1.8.1, I'd actually had several agents critique parts of my code. And I also stress tested it on large problems, not just on test cases. And all of these reveal some problems. So for example, there were some access conventions that are being ignored, like for example, zero-based versus one-based. There was some old code hanging around from the earlier CVXR that I could have gotten rid of. And then in the haste to actually get the tests all working, the agents had used some very bad algorithms where they were accumulating lists, order n squared list accumulation patterns were there. And then also eager solver initialization, which means that everything was sort of being initialized at startup, so everything was slowing down. There was also code. By the way, every time I got the code, I made sure that I looked at the code, not just take everything for granted. That's important too, because sometimes there are some non-R-centric constructs that, I mean, no well, person who actually knows R well would actually make those constructs, but I think these guys will go ahead and do it. So it was also using sapply for returning some unpredictable types. And also, one thing I really wanted to always make sure was there was no exported mutable global state. I don't like global states. They always bite me in the butt. So lots of things like this we discovered. All the tests pass, of course, but I think the critique found other issues that I think I would not have found out if I just let it go, continued on developing without doing some kind of self-criticism. So here is an example. So I actually want to sort of highlight this little exchange I had. So actually, let's look at number 2 here. So here's a simple problem where I'm minimizing the sum of some matrix entries. And it actually sort of had this little test example that sounded fishy to me. If you look at the constraint list of x1 greater than or equal to 1 e to the minus 6. Well, 1 e to the minus 6 is pretty small. So why are you using that rather than say 0 or something like that? And besides, this problem really has essentially no constraints. Okay, but all you're asking is x greater than 0. So all it says is, oh, the solver crashes on empty cone. So let's add a loose bound. I didn't tell it to do that, but it'll make up things like this. So I had to sort of insist that correctness was paramount and don't make up a cone spec when there's none. So I had lots of things like this. I've of course edited out my actual curse words and so on, but there are several of these that I've found that it'll do all kinds of things just to make the tests work. So I think that once you discover something like this, it always helps to make a full pass to see where else has it made such kind of assumptions. And this second one, by the way, is a really important lesson for me, which is the fact that just because people talk about vibe coding using testing, for example, I think just the other day I was in Berkeley and one of the people said, oh, we are actually doing, how about, no, we are able to do some things just by vibe coding and just tailoring things to tests. I think that's a wrong approach. The reason is that the reinforcement learning, for example, just rewards making the test pass. So, and these things will do things so fast that you will not know that it went and screwed up some actually correct code just to make the test pass. So there are lots of examples like that I actually encountered. So I became quite a skeptic in just checking whether if test pass everything is okay. No, I think that when you catch even one error, even if the test pass, you need to sort of do a full audit just to make sure that you're not deluding yourself just because of test pass. So this is, I think, a key thing that actually has helped me in newer projects going forward. And also, I think that one of the things you always ask the agent to do is to comment the code and its thinking. So you can actually put that down as a rule, mandatory rule. And that helps you because then when you find something, you can, so for example, here, there's all kinds of comments that it emitted that because I asked it to, that later on I could go and examine to see why it went wrong, for example. So there are silent shape mismatches deep in the C++ bridge, and I only was able to find that because one of the dependencies failed and so on. So these kinds, asking the agents to actually comment their code with the reasoning that they think is correct for it is helpful. So it comes for free, by the way. They'll do it in seconds. So I think I find that to be a very useful tool to be able to tell the agents. Okay, I'm going to skip this in the interest of time. I'll share the slides, by the way. So yeah, this one was another important one, which is that despite my exhortation to say, oh, you should follow CVXR fully, there was one important indexing that was completely dropped. For example, this Boolean indexing in R. And I actually felt pretty idiotic thinking that, my God, how did I allow it to get through in 1.8.1? But what helped me here was actually something else, which is the fact that um, um, CRAN always has to, you have to do reverse dependency checks. And when I did that, one of the packages failed. That's how I found it. So um, anyway, so there are a few ways that you can discover bugs. And by no means am I certain at this point my code is completely bug-free or anything like that. But I think that I'm pretty certain that I know the CVXY code very well for a long time. I've known it for over a decade. So I know I've checked every part of my generated code. And so I know that it's doing at least the right thing or what looks to be the right thing. So I think a human pass is always important, I think. All right, so I think I'm going to move quickly in the interest of time because I'm already at 30 minutes almost at this point. So I want to sort of thank Grant for the reverse dependency requirements because that helped me. And again, the idea that you should actually have an audit that makes sure that you cross-reference with the score with the actual truth is important. So here is my working methodology because I'm sharing this exactly as I do these days. So I always watch the AI's reasoning in real time. So I don't let it do something completely unsupervised. I'm not comfortable with that. So I read, and it goes by pretty fast. So you have to if it starts wandering off the track, you can actually press escape to stop it and actually question it. So for example, why are you planning to do that? What is the reasoning behind it and so on. And then you can add a rule to claude.md or agents.md or skills, whatever you want to sort of prevent it in the future. And the rules accumulate and it sort of gets better over the time. Now, I think that sometimes, by the way, the context window plays a role too. So I always have, in my session, I always have a dashboard that tells me the context, how much of the context it's used and so on. So as the context fills up, I trust it less and less and less. And so I'll compact it and ask it to come back and read and get up to speed and so on and so forth. So I think that for small tasks, you can do unsupervised is fine. For example, a translation of a single function, yeah, I'm pretty certain that these things are very good at that. At least Claude is very good at it. And then when you're doing things at scale, though, that's not fine. You actually have to check things. There's another important rule that I'm going to skip over this too, that I want to sort of go over, which is this number 6, by the way. So I think number 6 is a very important principle that has helped me not just in one project, but at least in another. After I finished CVXY, I've used AI for at least another 7 projects and large ones. These are not small ones, quite large ones. And I find that principle number 6 is actually a very, very useful one for me. I think that I don't know I don't still have a way to sort of completely describe it, but this is what it is. So how did I land on this principle? I watched the formalization of mathematics, and there was a talk that Terry Tao gave, and he talks about he used this, he formalized his proof in Lean, which is this proof assistant that actually can verify proofs and things like that because it has a complete set of mathematical truths and it can actually make sure things are logically deduced and so on. And so he came up with this idea of this blueprint discipline. And so this blueprint for us is the plan. And for them, Lean is the verification. And so the two stay in lockstep by cross references. So I think that there is somewhat of an analogy between the two. So this is the source of my thinking about this. So whenever I have a project that actually has dependencies and has a lot of interdependencies and also connections with other classes and other nodes and so on and so forth, anytime you actually ask it to sort of plan something, you always ask it to do a sweep down and a sweep up, because I think that this is what helps you make sure that you're aligned all the time. And I think that I did this almost in a sort of a anal fashion. And because I was afraid that so large a code tree would go so far out of sync, because these things write code in seconds, that I would not be able to get back. Oh, and also, it goes without saying that I'm using GitHub, Git repositories all the time. Every time I commit something, I make sure, even the smallest change, I commit it to a hash. I ask it to note the hash, and I ask it to sort of have a one-line comment so that I can always reverse back if necessary. So how would I describe this principle, this tree sweep principle? So I think the main thing is that um, okay, I'll come to that a little later. So here we go. So these are examples of things that the sweep found. For example, there was a quad over lens shape mismatch. These are details only that are only of interest to probably CVXR programmers. Dispatch audit. So this dispatch audit is something that you'll recognize, I'm sure, in bioconductor as well. There was silent demotion of S4 methods by S7 wrappers, and that was a painful thing to sort of discover. And then the downsweep basically walks each leaf of the blueprint. Does a single atom canonicalizer dispatch table do what CVXPies does? So it's actually sort of matching what the blueprint is. And then the upsweep is basically, making sure that they compose the right way. It catches export gaps, boundary where they meet at the boundary and so on, API alignment on those kinds of things. So I think that this is the only, how do you put it, succinct way I can describe this tree sweep. So I've been using it left, right, and center, but I'm still not able to sort of formalize it as a principle in any way. But this has helped me. If you have other ways of thinking about it, I'd be interested to know. So, okay, what do you do when you don't have a blueprint? But the nice thing about it is the fact that for CVXPy, I had a target. CVXR, I had a target. But most often, you don't have any of those things. But I think the key thing is that even a small plan can become a blueprint if you just start with it and have the discipline of adding to it. As long as you do that, it really does get better. And in fact, the AI also can actually help you define the blueprint. All right, so I think, how am I doing for time, Robert?
Oh, you're good.
Okay, so I think that, every time you plan something, make sure you critique it, because after all, LLMs are still stochastic. I mean, the point is that one agent will show something the other one won't. I mean, there's a stochastic nature to it. So you actually want to do it in a different agent, as a different agent that actually starts ab initio, so that it doesn't carry forward all the context that it has, and actually discovers things, and it may find things that may might have been missed. It can also sometimes mislead. Okay, I should say that too. There are many cases where it said something was wrong when I actually verified it. I said, no, that's not wrong. That's perfectly okay. So that also happens, but not that often. But it's I should say it's not. The probability is not zero. Okay, and actually, this is the way I think about any kind of a project. Now, I actually think of myself as a conductor, a music conductor, and at the score, I have to have some kind of a score, and so that's the blueprint or whatever. That's the authoritative thing. And these guys are all agents, and they're capable, but they need direction. And the rules are the way I sort of make sure they actually produce something that is actually faithful to the score. And one nice thing about it, I've also did this as well in my development, which is that because these guys can write code so fast, you should not be afraid to throw code away. Sometimes when it actually has gone wrong, there's no point in actually sort of keeping that and trying to patch it up. Actually, it almost doesn't make sense to me. I just actually toss it and begin anew. That seems to be, I kill the session, start anew, come up to speed, and then plan and proceed ahead. This planning and this critiquing thing takes time, but I think it sort of helps in the long run. Okay, so we are at 1.8.2 in R and so on and so forth. Okay, that's fine. So here, this is the part that I think is probably more directly applicable to you. So the main thing I wanted to sort of focus on is this method in S7 for choose ops method, because this is what caught my eye. This is what makes, for example, dispatching possible. So this was, I think, this was debuted in R 4.3.0 in April 2024. Okay, so I've been watching the development of S7 for a while, but I think that once the blog post on this came on in the R developer blog post, it really made me think that, oh, something like this I should be able to do in S7 now instead of S4. So here is a simple example. So in CVXPy, a user will write, for example, you create a variable X, you have an identity matrix A, and you want to create an expression which is A times X plus 1. And you want to minimize this expression subject to the condition that X is greater than or equal to 0. The problem is that every operator here, the at, plus, and even the exponentiation inside the sum of squares, all of these things have to be overloaded. So, in Python, we have all these things available. So, for example, in Python, you can in CVXPy you have these methods called expression dot underscore underscore add underscore underscore other. So these are called dunder methods, for double underscore methods. So in R we have it for ops dot expression E1 E2, but so the other part is, for example, suppose you want to say right add or left add. So R only does one side at this point. And so you also have to think about matrix multiplication and so on. So here is the simple summary. I'm only going to focus on, say, S4 and S7 here. So both are multi-arg arg dispatch, and I think that S4 does now, S7 now does 2-class dispatch. I think they mentioned somewhere in the documentation they could do more than that or something like that. At least it's not explicitly forbidden. My memory may be wrong. Okay, so I think that these people have carefully thought about it, I think, and they also made it nice so that it all works beautifully with S3. So under the hood, they use use method, and S7 classes also set the class attribute. So which means that S7 cooperates nicely with with all the S3 dispatches. Also, you can also work with S4 using S4 register so that you don't destroy a matrix style object or a method, for example, a generic method. So this thing came in useful. So here's an example. Suppose I have two objects and I define a plus method on it. If I just go ahead and add the two, so the addition succeeds, but I do get a warning that says this is incompatible methods. And also what I expected was something of a class foo or a bar, but instead I got a numeric 2 or integer 2 or whatever. So neither method ran, but it fell back on internal arithmetic. So there's a silent success. The expression succeeds, correct, but it only emits a warning. In fact, I want this to fail. I don't want something like this to happen for CVXR. So this will produce the wrong object in my case. So I could sort of build upon this choose ops method. So, and this is the key part, because this lets me explicitly define how the methods, when you have a left and a right method that might work, how you could sort of, articulate the competition. So here, X and Y are the two operands, for example, and MX and MY are the two competing methods that maybe apply, and CL is the original call. And reverse tells you, whether it works after true or whether you swap and then it works and so on and so forth. So here's an example. So how does this whole thing work? When you have two competing methods, MX and MY, R first calls choose ops method. So if it is true, if it returns true, it runs the first method, MX. And if otherwise, it just calls it again with the operand swapped, and reverse equals true. If that is true, then it runs that method. Otherwise, it goes back to legacy methods fallback. So this is the kind of equivalent of RAD that I needed. So this is where everything worked nicely for me. So now here, for example, uh, I could the choose ops method. I could have bar win both ways. So this is a crucial uh, advantage that now I have, and I think that's why they probably wrote this nice blog post. Michael Lawrence and Luke Tierney and all the others, for example. So this is actually a blog post. Have you seen it, Robert?
I haven't.
Okay, it's a nice blog post that actually kind of describes all these details and so on and why they did it. So I think that's what sort of caught my eye. So now I could actually, this is actual code here. I could have a CVX ops handler. I need to handle Unity minus, Unity plus, and not X and things like that and so on. So there's something I still have to do with S3. But basically, here is the simple piece of code that basically just handles all the 11 operators for me. And I can handle both Unity and binary forms. The Unity form, of course, pauses. Of course, I have this all registered on load. And let's see. Yeah, the reason why I need the S3 ops for Unity thing is because of the fact that how S7 methods operate. Suppose I have a method for, say, minus for list expression in class any, then I have minus dot CVXR colon expression that takes precedence over both unary and binary. So I need to somehow mitigate that. For that reason, I have to sort of, for the unary part, I have to sort of make sure that I use the S3 ops group. Okay, so, and there's something similar for percent star percent, but that's in matrix ops. So I had to handle that as well. So I think that in the end, I have no set method declaration anywhere that mentions sparse matrix. If I want to do something like this, CVXR knows nothing about matrix, matrix knows nothing about CVXR, and they compose because of one S3 method, choose ops method dot CVXR expression, and two S7 methods, which is because for this matrix part, I have to do that. That's all. So, and I should also mention that this is a problem that actually was only present on S7 0.1x. This has since been solved in 0.2, so I don't think I'm going to go into that in detail. So I think S7 continues to be developed, so I need to sort of probably still go back and look at my code for CVXR and fix up some things that I had developed before these fixes were made. So, okay, the final summary is that S7 became a credible target for CVXR rewrite when we had the choose ops method added. And one line of choose ops method replaces dozens of set method declarations. And this is what CVXR expressions, let's say all the CVXR expressions compose cleanly. And so, for example, I could use a delayed array class without either side knowing about the other. I should be perfectly fine. So, all right. So I think I'm going to stop there and stop for questions. So you can take a look at this. And I want to also acknowledge Angie's work that made this all possible. Thank you.
Great. Thank you, Naras. That was quite helpful and insightful. Early on, you sort of drew some comparison in timing between the old version and the new version that seemed pretty dramatic.
You did. I think, yeah.
Mostly around just getting the conversion from a sparse matrix to a dense matrix down, or were there other things? Was there a lot of copying that was going on?
I think actually it was not in the dense sparse versus dense. The sparse versus dense problem was only for the quadratic problems when the objective was quadratic, like sum of squares or something like that. But that was a very focused fix. It actually was more to do with the fact that there was a lot of copying going around.
Yeah. I mean, one of the real downfalls of the S4 approach is, right, you have a big structure that has, say, a gigabyte worth of data in it, and then like four parameters that are binary, and changing one of those four causes a copy of the entire
Hmm.
um, structure. And so that seems to me to be something that we likely are facing inside of some of the bioconductor class structures as well. And we need to sort of think a little bit more about methods that allow us to keep the small scalar stuff outside of the big data stuff, which does, I think, get us closer to reference type data structures.
Hmm. Yeah. Uh, I should also mention that when coming back to your previous question about also the slamming, I think S7 is now an outside package, but I think that there's also somewhere, I think in the documentation I saw that maybe base R is going to adopt it at some point. If that is the case, it should also yield some more efficiencies too, I think, because it'll be part of the dispatch thing should be slightly faster, I would think, in that case.
Yeah, we'll see. It's always hard to do those things. Do you have any thoughts or any advice on like sort of shared development? I know, this in a sense, you and Anshi were working on this, but if you had a collaborator a long way away, how do you think these sort of code development tools are gonna work in that setting?
So I actually think actually it involves I've thought about this quite a lot now, and I think the thing that I think would work very well
Yeah.
is with Git and a GitHub. Say for example, you can actually have Git and a sort of a GitHub server. I'm just using GitHub as a stand-in for that. But once you have that, for example, and you use the GH command line, you actually give the Claude some permissions to say, oh, I need you to commit this every time. And what you could do is that you could actually have the agent checklists sort of written in a way that they all converge on the GitHub repository so that they are immediately aware and they can actually monitor that. They can actually also have a background agent that actually monitors any pushes to the repo, and they can immediately adjust and also inform the
Right.
developer if something has changed that would actually be an incompatibility and so on. So I think that I actually have thought through this, and I think that I've done some little experiments, but not with two people, but I think that not with say 5 or 10 people or something like that. But I think that it's doable. I actually think that this is, but I would not again. I'm still quite skeptical about unsupervised stuff. I mean, I think that that doesn't work for me so far.
Yeah, I mean, I think, as you pointed out a few times, it's really easy to generate a ton of code, right?
Yes.
It's it's very hard to, I think, review a lot of it. I mean, you sort of get the big snapshots, right, of at least my experience. Every now and again, my project, suddenly it's like, oh, you're going to commit 1,000 lines of code for something that's, a pretty trivial idea, and you sort of have to try to figure out where in that it went wrong. I've personally gone down the line of really always trying to have a design document that I produce, and
Hmm.
am very careful about vetting, and then an implementation document that I spend probably as much time on,
Hmm.
and keep those structured in the commits to the GitHub repo, just so that if anybody else is working on the same project, they can sort of point things to the agents.md and the design documents.
Yeah. Yeah, I mean, but one of the things also is the progress. You can also
Yeah,
record the progress, everything.
yeah,
Yes,
yeah,
I 100% agree on that. I should also say that the part there. This also these things experience has also taught me that where things are really good enough that I actually at this point I would trust things. For example, if you have some C library or something like that, you want to generate some wrappers for R,
yeah,
problem.
yeah,
It will do it pretty well. You point to say, okay, I want C++11 wrappers or RCP wrappers. Okay, it can do that. The part that you also have to make sure is, for example, you want to say, wait a minute, I want make sure don't make a copy of the matrix that is being passed. I want an eigenmap of that, or I want an eigenreference of that, or something like that, because I don't want unnecessary copies. And so those are all things that you have to tell it in some sense. It will not do it automatically,
Right.
right? So you have to think through those parts. And then the other part also is that, yeah, the documentation it saves me so much. I have a bad case of carpal with Emacs, so it just helps me so much to the end. I mean, I think that
Yeah.
so there are several things that I think I'm very happy to delegate, but not the thinking part, as you correctly say.
Yeah. Yeah, and I was kind of intrigued by your examples with the test passing. I think there's some more work that we can do in that space to try to um, figure out, like, how to identify situations in which, the large language model has somehow manipulated the test itself to get the reward of being completed, as opposed to, making sure that the test actually checks what you want. Or, even in the case, like, I think I'm reasonably publicly on record in some sense of not being a big fan of unit tests, because I don't think they test in general things that are particularly useful to test. But I'd sure like to catch them out. And I've been trying to get some data from the large language model around what is my test coverage? What are you actually testing? Are these, what do the examples look like? What are the inputs that you're trying to work on? And it's been fairly opaque for me. I really
Mhm.
haven't gotten anywhere.
Yeah. No,
But
I think that's the most nefarious part because I that was pretty sneaky, and I caught me by surprise that it actually slapped in 1 e to the -6 somewhere, or you've changed some positive semi-determinate matrix into a second order cone program and things like that. It was very weird. Yeah.
Vince, do you want to?
Hi,
How about
Vince.
now? Can you hear me?
Yep.
Yeah.
Okay, here we go. I came in a little late and you were talking, I think, about 7,000 tests
Yeah.
that have been run. Now, one of the things I've been looking at lately is property-based testing with Hedgehog. Have you had a
Mhm.
look at that at all? Is that what you were doing to generate them?
No, I know for me it was very clear, right? I actually could say for each test in CVXPy do X. So I was pretty much. By the way, I was learning as I was going along, so I didn't do the Hedgehog test. No, I didn't do that. This were all pretty much driven by what I saw in CVXPy. But I think that's an intriguing thing. I mean, I've thought about stuff like that, but I've not had any experience doing it actually.
Yeah, it does seem that I use Claude and it seems to know how to produce tests that have an interesting character and then have stochastic inputs to them to see if you can find corner cases that you didn't anticipate.
Mm.
So it may be
Well,
worth trying out there.
yeah, so I did. So this again to be concrete. As I said, I had thought about this. So the place where I used it is, for example, we're going to have a soon a release of GlimNet that pretty much gets rid of all the Fortran, and so now we have the Cox model with Efron ties and things like that. So the Efron ties is exactly one of the examples of the flavor that you're talking about, because there the edge cases actually make a big difference, and we got some tests that actually were very good indicators of where things could go wrong and so on. So and we were able to compare it with Adili and stuff like that. So to an extent, I've played around with it, but I've not really gone in a disciplined way at it. So I have to look at it.
Right, great. Thank you, Naris.
Thank-
And thanks everyone for coming. I appreciate the support. And as I said, if you have ideas for other topics in this series, we're hoping to be, really focusing on using agents and large language models for software development in here, and trying to find the places where, as Naris has pointed out a few to us, here's some places where it seems to work really well, and here's some places where you really want to be more careful. And hopefully we can build up some community resilience within this whole arena for both R and bioconductor. I think there's opportunities to do software maintenance, keep the code up to speed with a lot less resources than we've been putting into them. And I think having that available to us in Bioconductor will enable us to use more of the resources we have to do some of the stuff that we just couldn't get to because of the amount of work that needed to be done.
Thank you, everybody.
Thanks.
Yeah.